All right, let's go forward then. Here's your examples. Identifying growth and decay. Identify each function or situation as an example of exponential growth or decay. What's the y-intercept? 2 examples today. Number 1, y equals 3 times 4 to the x power. I need to know if it's growth or decay. I'm going to ask Jason Lewis. Yes. Jason, you have one more thing to answer for me. What's the y-intercept? Yes. Y equals 11 times 75 hundredths to the x. I'm going to ask Matthew Sweeney, growth or decay? And the y-intercept is? Look, what was Jason's y-intercept?
0.
Perfect. Questions on problem 2?
Problem 2 is decay, right?
Yes, problem 2 is decay because the base is less than 1. Okay. Let's go forward. Maybe. I can try. All right, let's keep going. Okay. For exponential growth, y equals ab to the x with b greater than 1. The value b is known as the growth factor. When you have exponential growth, the quantity increases by a constant percentage each time period. Increases by a constant percentage each time period. Very big with population type stuff. The population increased by 5% this year. That's exponential growth.
Why Ebola came around, the government's trying to kill us.
The percentage increase, R, written as a decimal, is the rate of increase or the growth rate. When you know the growth rate and need to find the growth factor, the growth factor B is 1 plus R. For exponential decay, that value B is the decay factor. If growth increases by a fixed percentage each time period, what does decay do? Decreases by a constant percentage each time period. Instead of being the rate of growth, what do you think we're going to call it? Yes, it's the rate of decay. Or the decay rate. Usually a rate of decay is expressed as a negative quantity. Therefore, B is still going to be 1 plus R. It's just the fact that R is going to be negative. We model exponential growth or decay with this function. A of t equals A times the quantity 1 plus R to the t power. A of t represents the amount. It's actually the amount that you have after you go through so many time periods. A represents the initial amount. It's what you start with. R, of course, is the rate, be it growth or decay. And if it's decay, you just simply represent it as a negative number. And T, of course, represents time. Remember, for growth or decay to be exponential, you change by a fixed percentage each time period. Math will be harder. I agree. Okay? All right. So let's get you some examples of what I expect you to do today.
I just need a will.
Write an exponential function to model each situation. Find each amount after the specified time. So as long as he tells us to write an exponential function, we know that we're going to be writing something in this line. A of t equals a times the quantity 1 plus r to the t power. Take a look at our first example. A population of 1,236,000 grows 1%, 1.3% per year for 10 years. Guys, what's the 1,236,000? Which variable is that?
A.
Very good. The 1.3% is,
The rate.
and the 10 years?
T.
Time. Your 10 years. So when we go to write our answer, A, of course, is the 1,236,000. Of course, we have to express the rate as a decimal. Right now, it's a percentage. It happens to be a percentage with a decimal in it. But what is 1.3% expressed as a decimal? Correct. So added that to 1, we get 1.013. And t is 10. So here is an exponential function to model this situation. The initial amount, 1,236,000. The base, 1.013, because it's 1 plus 0.013. And the time is 10. Grab your calculators. Don't put it in the y equals. Put it in a regular calculator part. Tell me what answer you get. And since we're talking population, round it to the nearest person. Hit second in mode, the key right next to it, and that will get you out of your graphing.
236.
How did you get the 1.013?
What is R, Mr. Bruner?
1.3.
Change it to a decimal.
1.3.
No,
1.3.
move it 2 places.
0.013.
Add it to 1.
Okay.
Okay. Mr. Sweeney, your answer is?
I think it's 51 million.
I think it's 100.
I don't know. I think they're all.
Not 51 million. Miss Hummel, your answer was?
1,406,413.
That population will grow to 1,406,413 people in 10 years. All right. So here's the last thing I want you guys to be able to do today. Last slide, 12 of 12. For each annual rate of change, find the corresponding growth or decay factor. Don't worry about the fact that it says 17 through 24. I just copied that off of a worksheet. If I give you a plus 45% rate of change, what's the growth factor? Add it to 1. 1.45. If I give you a decay factor in this case of negative 10%, or excuse me, a negative rate of change of 10%, what is the decay factor? Change to a percent. Oh, yeah, 0.9. Correct. What about negative 40%? 0.6. You guys, one of two ways you can do this, guys. You can either change this to a decimal, 1 plus 0.45, or you can simply take what they give you and add it to 100. And then when you get your answer, change it to the decimal, 1.45. That's it. That is lesson 7-1.